Hello everyone, this is Team Sagar. We will be presenting our solution. So we start our solution by defining the plastic first, because in general life what we know as plastic and what we need to label as plastic for this problem statement are not same. For example, foam, sandal bodies, laminated paper plates are not considered as plastic in general life, but in scientifically and polymeric terms, they are plastic. For example, foam is known as number 6 plastic, sandal bodies are made up of semi-plastic material, and paper plates are, after laminating, they became non-biodegradable and become a major source of the plastic waste in the river. So if we want to counter the plastic problem, we must have to take them into account along with the polythene, plastic bags and other plastic materials. So after defining this and justifying the reason of adding them into the labeling as plastic, we will move on to the RoboFlow. In the RoboFlow, we labeled all the images one by one and have repeated it for all the data set, not only train, trace, but also the predict. After doing that, we exported them, and after exporting, we as it can be seen, predict, test, train and data yml, these four files and folders we got from the exportation. Now after exporting that, we made a new file, new notebook. Now in this notebook, what we did, we trained the pre-trained yellow v8 model on our custom data set for 400 epochs, and we take the image size as 1024, which will give us more detailing. Means that we can generate or predict even the small number of plastics, or the even the small size of plastics. So this will help us. Now after running it for 400 epochs, we exported the model in onx format, and after doing this, we evaluated the model. Just after evaluating, our next task was to check that whether our model is working or giving the result or not, or how it is working. So we in the predict folder, we created another image folder and stored these images, and we are going to predict those images using our own model. So as you can see that final model.onnx, this has been copied here, so that we can easily use with the relative path. So we are opening the working of model notebook, and in this notebook, what we did, that we first install the pillow, and then imported the required packages. So we are not installing the pillow again, since we have already installed, and already the ultralytics is being installed. So we will not run the third command. Also we will run the fourth command. The fourth command will return us the geotag url. Now the fifth command is about the dependency, and now the sixth command, what we'll did, that the sixth command will load the model, which we have just shown the previous slide. Now after doing this, we will run the final cell, and here we can see that first it is printing the name of the file, and after that you can see that it is predicting that how much plastic are there. As you can see that 38 plastics it is mentioned, and it is also generating the geotag link. Same it is doing for the other images in that folder, and one by one all the images in that folder has been run through the model and gave the result, and stored that, and all the results are saved in this folder, and everyone have them given the geotag url. Now when we click on the geotag url, it will redirect us to the Google Map website and pinpoint the exact location from where the photos were taken off, or the photo was taken off. So as which will later help us in planning river management or river solutions. So that was from that. Now after doing this, if we want to check that how our prediction looks like, we need to just go to this folder or this directory, and we will find that how our prediction looks like. So we will go to that directory. So here, as you can see that it was in runs, detect, predict, and these are the results. So we will show you the results one by one. As you can see that most of the plastics are predicted perfectly. So same for the second image, and for this image also, and the other images have also quite good results. So we can say that our model has been a effective solution for the problem statement was given, and it can be helpful in solving the river plastic issue, or the floating plastic problem in a river. Now giving this solution, we are very much thankful to the organizers and all the authority who are responsible for conducting this event. We are very much thankful. for giving us the opportunity to present and do such a wonderful job or contribute to for a real world problem, for the solution of a real world problem. We are thanking you.